Assalamu alaikum, my dear students. How are you all? I hope all you are fine. Alhamdulillah, by the grace of Almighty Allah, I'm also fine. So here I'm again with a new revision class of science. You already know me. I'm Shanas Parveen Asha from English Medium Senior Section, Sector 11. So we have passed through a long time. Today's 47 number class. Okay. So I hope you all are ready with your book, copy, and your accessories, pen, pencil, whatever needed, and obviously with full attention. As it is science class, you know that if you lose your attention, in that case you will not get the lesson properly, is it? I know you know this point properly. So with a proper attention, do the class and obviously learn all the knowledge based question answers, all the comprehensive based question answer, and whatever the critic question is discussed with the answer, you must learn it properly. Okay, I hope you will learn properly. Let's enjoy the class. So here is Milestone College English Medium Senior Section. My today's class is on science. I have already told it. It is of class 8. And your teacher Shanas Parveen Asha. I'm from English Medium Senior Section, Sector 11. I take Science and ICT of 8. So our today's class number is 47. You all know. Last you have done class number 46. Okay. Then our today's topic is of revision class, obviously. And on chapter 11, our chapter name is Light. And we will revise today lesson 1 to 7. Okay. So open all your page number 114 to 118. Okay. Now we are in light, is it? So before proceeding light, we should know what are the media, because here we are learning refraction of light. Okay, so here when refraction happen, only when light passes from one transparent medium to another transparent medium. So what are medium? You already know mediums. We are getting two type. Transparent medium means water, air, glass. Okay. So we are getting two medium. One is rarer, that means which one is less condensed, and the one is denser, which one is more condensed. So if I ask you a question that compare water with air, which one will be more denser and rarer? I hope you can answer. Yes, water is denser and air is rarer. Again, glass with air. Obviously, glass is rarer, glass is denser, and air is rarer. Very good. Next one, if you compare water with glass, then obviously it is a matter of molecules. Okay, molecules, when molecules remain more compact, that time we get solid. So glass is solid and water is liquid. So water is here rarer and glass is denser. Very good. I had given this part in a previous class also. I have kept this one here only to recall your mind. So our chapter is all about refraction of light. What is refraction of light? When the ray of light travels obliquely from one transparent medium to another medium, the bending of ray of light at the surface of separation of the two media is called refraction of light. So one thing I should tell again and again, that light doesn't bend actually. Okay, light doesn't bend actually. So I said light doesn't bend actually, it changes its path. That is the main fact. Okay, keep in mind. Next one. So, as you have learned all the laws and you have seen changes of the laws, so here was the video about the laws of refraction of light.
In the previous video, we learned what refraction of light is. Refraction of light is a transmission of light through an object in which the light which is incident obliquely bends at the boundary of the two media. We also said that the bending of light in the medium is caused by the change in its speed. When light is traveling from an optically rarer medium to an optically denser medium, its speed decreases and it bends towards the normal. When the light is traveling from an optically denser medium to an optically rarer medium, its speed increases and it bends away from the normal. In the figure, the case above is from optically rarer to denser, and the case below is optically denser to rarer. But how does the change in speed result in the change of direction of light? I did mention in my previous video that we will understand this with the help of an analogy. For the next few minutes, just forget everything I told you about anything related to light and just concentrate on what I'm about to show you. Here's a shopping cart which has rotating wheels. Say I want to move this shopping cart from the road to the grass. Obviously, I will push it or apply a force on it. Assume that I will apply a constant force throughout its journey. Let us see what happens when I start to move from concrete road to the grass. What did you notice? As the wheels of the cart entered the grass surface, their speed reduced. The cart travelled at a much lower speed on grass than on the concrete road. And the reason for slower speed is rather obvious. The grass offers more resistance to the motion of the cart than the concrete road. Here, we can consider the concrete road and grass as two different media through which the cart is moving. Note that the direction of the cart is same in both the media. We can think about light in the same way. Something similar happens when the light is travelling perpendicular from an optically rarer to an optically denser medium. The optically denser medium offers resistance to the flow of light and hence its speed reduces. However, its direction does not change. Let's get back to our cart example. What will happen if the cart enters the grassy surface at an angle? Let us see that. This is how it would look. Now let's take the cart back to the original position on the road, and we will look at the movement very slowly. As the cart approaches the grass surface at an angle, its right wheel will enter first, and as it enters here, it will slow down. At that time, the adjacent wheel is still on the concrete road and is hence moving with the same original speed. So the wheel on the grass surface will move slower than the other wheels for some time. But let's focus on the two front wheels. Both the wheels are moving with different speeds. As the force applied is constant, what this will do is slightly turn the cart towards the right. The cart will change its direction and continue moving in that direction afterwards. So the direction changed. Now let me draw a normal to the surface now. We can see that the cart has taken a turn towards the normal. If the surface wouldn't have changed, the cart would have continued to move in this direction. But because the surface changed, the direction of movement of the cart also changed. Why am I telling you all this? It's because one can think of bending of light in the same way. When light is obliquely incident on the surface of an optically denser medium, its speed decreases and it bends towards the normal. Part of the beam that enters optical medium first slows down, making the entire beam to change the direction towards the normal. Now let me ask you a question. How will the direction of light change when it enters an optically denser medium to an optically rarer medium? Will it move towards or away from the normal? To answer this question, let's switch back to the cart example. This time, the cart is here on the grass and it's being pushed towards the concrete patch. What will happen here? This is how the direction of the movement of the cart will change. Why? Let's see the animation slowly. As the cart begins its movement, the right wheel will reach the boundary first, and after entering the concrete patch, its speed will change. Will it increase or decrease? It will increase. It's because the friction is lesser on the concrete road. So now, this wheel will move with greater speed, but its adjacent companion is still on grass moving at a slower speed. So the change in their relative speeds will turn the cart towards this direction. If I draw a normal, you can clearly see that it's moving away from the normal in this case. If the surfaces were the same, it would have moved in this direction, but as they are different, the direction as well as the speed of the cart changes. We can apply the same analogy for the light entering from an optically denser medium to an optically rarer medium. Light can propagate more easily in an optically rarer medium than in an optically denser medium. In such a case, its direction of propagation will be away from the normal in the refractive medium. One last question to which you will definitely know the answer to. What if the cart is entering the concrete like this, perpendicular to the surface? Yes, its speed will increase, but its direction will not change. So if the light is entering an optically rarer medium in a perpendicular manner, then its speed will increase, but its direction will not change. In the next video, we will talk about a few examples of refraction.
Okay, hope you enjoyed and obviously you did understand. Is it? That's a video on critical angle and total internal reflection. Because this lesson you have learned, I don't want to discuss anymore. I just want to show some videos.
Critical angle and total internal reflection. In our earlier session, we have learned about laws of refraction. We had learnt earlier that refraction is the bending of light rays at the surface of separation from one medium to another medium of different densities. The light ray passes from rarer medium to denser medium. When it passes from rarer medium to denser medium, it bends towards the normal line, and when it passes from denser medium to rarer medium, it bends away from the normal. The angle between incident ray and normal is called as angle of incidence. The angle between refracted ray and normal is called as angle of refraction. When the light ray travels from higher density to lower density in different angles, the refracted ray bends from the normal, and the angle of refraction is greater than the angle of incidence. When angle of incidence increases, angle of refraction also increases. At a point, the refracted ray takes the path along the water surface, and the angle of refraction is less than 90 degrees. When the light ray passes from denser medium to rarer medium, the angle of refraction is 90 degrees. The corresponding angle of incidence in the denser medium is called as critical angle. Total internal reflection. When the light ray traveling from denser medium, if the angle of incidence is greater than the critical angle, then the light ray doesn't enter into the rarer medium and reflects back into denser medium. This phenomenon is called as total internal reflection. During the phenomenon of total internal reflection, the light ray doesn't get absorbed or transmitted or refracted from the surface of separation of water. The light ray always gets reflected back into the denser medium.
Okay, hope you did understand. Now come to the knowledge-based question answer, as it is revision class. So our first question, what is called refraction of light? You already know the definition, though I'm repeating. When the ray of light travels obliquely from one transparent medium to another medium, the bending of ray of light at the surface of separation of the two media is called refraction of light. Next one, what is called critical angle? For incidence from a denser to a rarer medium, the incidence angle for which the angle of refraction becomes 90 degree is called critical angle for that pair of medium. So one thing, you must have to write that pair of media. Okay, because to get a critical angle, there must be two media. There must be two media. Medium. Next one, what will happen when a ray of light enters from rarer medium to denser medium? The ray of light bends towards the normal, and in this case the angle of incidence will be greater than the angle of refraction. What will happen when a ray of light enters from a denser medium to a rarer medium? Yes, the ray of light bends away from the normal. In this case, the angle of incidence is smaller than the angle of refraction. So what will happen when a ray of light is refracted from one medium into another medium and finally emerges out in the original medium? Tell the answer. I'll not tell. Okay. The angle of incidence is equal to the angle of emergence. Next one, what is called total internal reflection? Yes, when a light passes from a denser to a rarer medium and incidence at an angle greater than the critical angle, the light comes back to denser medium obeying the laws of reflection. Okay, so this is total internal reflection. 7 number, what will happen if the incident ray, the refracted ray and the normal drawn at the incident point on the surface separating of the two media all lies at in the same plane? Next one, in case of total internal reflection, light must pass from which medium? Yes, denser to rarer medium. 9 number, in case of total internal reflection, the angle of incidence must be greater than which angle? Yes, critical angle. 10 number, what will happen when a ray of light of incident along the normal? Yes, angle of incident, the angle of refraction and the angle of emergence all are zero. So no change or in direction of the incident ray. You all know this one. Now come to the comprehensive based question. First one, what is called refraction of light. The same question you have learned in case of knowledge base. Okay, so here what you have to do, you have to write a bit more. That means you have to write the definition as a knowledge based part, and then actually what will happen in case of refraction of light. Actually we know the light bends in the surface of separation. So how it bends, you have to write this one, or you can write any other information also. I thought myself that this part is enough for 2 mark. Okay, try to draw a figure also. So first part I have written the definition, and then I have written that where one transparent medium will be denser and another will be rarer. And when light passes from denser to rarer medium, light bends away from the normal, and when light passes from rarer to denser, it goes towards the normal. That's it. If you want to write other information like I thought that this is enough. Okay, so write this part. Second number question, why dull image form in the glass window? So now what is knowledge base part? When the light falls on the glass window, most of the light falls on it, passes through, but a small fraction of incident light refracted back, which forms dull image. Okay, this is the knowledge base para. And now next para you have to write the bit description. So what is that one? The glass of the window is the transparent medium. So when light falls, falling on it, most of the light passes through it. And due to the change of medium, a fraction of incident light comes back to the same medium. Okay. So in this image formation, light first passes from the air to glass and then again glass to air, and thus forms dull image. Next one, what will happen when a ray of light passes from denser medium to a rarer medium? It is the law we have discussed. So you have to write the law. What will happen? Angle of incidence is smaller than angle of refraction. Okay. And then how it happened with the figure you have to explain. In this case, you must have to draw the figure. And here, right here, the incident ray PO created an incident this T went inside the figure. Okay. Don't think that it is mistake. So created an incident with the normal PON and equals to I. That means it is the angle of incidence, and refracted ray OQ, and it created refracted angle. So I hope you did understand. 4 number, explain total internal reflection. So as it is of 2 mark, definition is not enough, so you have to write the definition, and with the definition it is better to write the condition in case of 2 mark, because you no need to discuss more points. Here what you will discuss, the figure you will discuss obviously in 3 marks question answer, not in 2 mark question answer in this case. Okay, but why? Because we have much more information here to discuss, to write. That means here you will write it will occurs when light ray goes from a denser medium to a rarer medium, and the angle of incidence in the denser medium must be greater than the critical angle. Okay. So here what will happen, corresponding to the pair of the media chosen. So I'm repeating again. In case of total internal reflection, you have to write the definition obviously first. This is the knowledge base part, and then write the condition with the figure. And in the figure, if you are not putting the direction, I'm repeating, if you are not putting the direction in the figure, your figure, you will not get a single mark from the figure. So you may have a question that for 2 marks question, why I will input figure. This figure is a very silly figure. You can draw with easily with free hand. Okay. Yeah, teacher will give you mark without the figure also. If you write this full information. This full information, if you could write, teacher will give you mark. But here one thing, that if you are giving something to someone with total happiness or with your gloomy mind, that actually you don't want to give, but you are actually bound to give. That's why you are giving. Which one you prefer? Answer me later. Okay. Next one, 5 number. What will happen when a ray of light passes from rarer medium to a denser medium? Obviously, this is also a law. So write the law, then explain the law with the figure. Okay, so direction is must. I said again and again, direction is must. Here you will write I, and here you will write R. This should be present. Now come to a creative question. Our creative question is, what is called refraction of light? Before that, we have a figure, and you see this figure you are habituated already, and this is in your book, science book, in lesson 6 7. You will get, this is the total internal reflection and critical angle together is present in this figure, is it? So our question is, what is called refraction of light? It is knowledge based. Then what do you understand by critical angle? It is understanding based. Then which one is denser medium between C and D? Explain with reason considering OQ ray. That means you have to find out this C and D, which one is what? Okay. And then considering OQ ray, you have to explain this one. Clear? I hope it is clear to all of you. So it is application based. Next one, whether incident ray RO comes back to the same medium. Is it? If it's yes, you have to explain with your logic. If it is no, though, you have to explain with your logic. Now come one after one. What is called diffraction of light? I'll not tell anymore. I have said it several times in this video also. Now, what do you understand by critical angle? Obviously, you have to write the definition. First, the knowledge base part, you will write definition, then draw the figure with the direction and explain. Like here, OP is incident ray for which refracted ray OP prime, and because of the angle of incidence, that means because of this angle PON prime and NOP prime forms, is it? So it is 90 degree, and as this 90 degree form because of this one, that's why this is called critical angle. That means incident PON prime is called critical angle. Clear all of you? I hope so. Next one, which one is the denser medium between C and D? So by the figure you can easily understand that as the direction by the direction, and you can see here the angle of this angle is smaller and this angle is greater, is it? So it happens when only light passes from denser medium to rarer medium. So first of all, you identify C is denser medium and D is rarer medium. Actually, this identification you can write at the end also, because you can explain the phenomena what happened here, and by that you got the point that it is denser medium, is it? So both way you can write. Maybe my word becomes confusing to you. Okay, let's come. Considering OQ ray as the ray of light, OQ is passing from medium to another medium, it bends away from the normal at the surface of separation. Okay, so we know from the law of refraction that when ray of light passes from denser medium to rarer medium, it goes away from the normal. In this case, the refracted angle become greater than the angle of incidence. Now, come to the figure of the book question. Here, Q prime ON is angle of refraction, which is in rarer medium, and QON prime is angle of incidence, which is in denser medium. Clear? That's it. So, come to question number D. Whether incident ray RO comes back to the same medium. Analyze your logic. Yes, obviously. Why? Because it passes critical angle. So incident ray RO will come back to the same medium following the laws of reflection. Okay. And following the laws of reflection, it comes back. This phenomena is called total internal reflection. This phenomena is called, yes, total internal reflection. That's why just after this knowledge base part, you will have to write the definition of total internal reflection. So when a light passes from a denser to a rarer medium and incidence at an angle greater than the critical angle, the light comes back to denser medium obeying the laws of reflection. Okay, so this is called total internal reflection. Now you have to discuss the figure. How you will discuss? Here OQ Q prime O reflected ray is traveling along with the boundary surface. So it is here the corresponding angle of refraction is 90 degree. Now for the angle of incidence, RO is greater than the angle of the critical angle. Okay. So in this case, the ray RO R prime O refracted back by the total internal reflection following the laws of reflection. See the figure. You have to draw the figure also like this. So it only occurs when, so when it occurs, that one you have to tell also, because it is a 4 mark. Draw the figure, explain it properly, then when it happened, what is the cause? What is the cause that the arrow ray is coming back to the same media? That one also you have to write. So what it is written here? It only occurs when light ray goes from a denser medium to a rarer medium, and the angle of incidence in the denser medium must be greater than the critical angle corresponding to the pair of medium chosen. Okay, so you have explained. Now just end the answer. So here RO ray comes back to the same medium. That's all about the credit question. Now what is the homework? Your homework. So write this comprehensive based question answer as homework. What you will write? What will happen when array of light of incidence along the normal? Explain. So what will happen when array of light of incidence along with the normal? So all will zero. The you will see the rules laws. From that law you will write this one. Explain critical angle, explain total internal reflection. I have written, so I'm not going to explain you. I have explained already, so you will learn and write from there, and you will write the conditions of total internal reflection. Write that two condition. What are the condition? Total internal reflection happens or occurs when the light passes from denser medium to rarer medium, and the ray angle of incidence must be greater than critical angle. Okay. Next on, what will happen when a ray of light is refracted from one medium into another medium and finally emerges out in the original medium? what will happen? Angle of incidence and emergence angle will be equal. Okay, that means if angle of incidence is 40 degree, angle of emergence will also be 40 degree. So you will explain with the law and with the figure, and that's it. So thank you all for enjoying my class, and I hope you did understand and focus properly. Obviously write the creative question and answer, and also creative question, comprehensive based question or their answer, and also knowledge based and their answer in your class or copy. It is obvious. Thank you all. Now listen to my word again. Okay, my dear students, that is all about today's lesson. I hope you have watched properly and learned and written all the question answers in your class or copy. Must write the comprehensive base 5 question answer which one I have given homework. Okay, I have tried to focus on the board question, and also I have tried to focus on the important topic of the lesson. So that's all today. Stay home, stay safe, or wherever you remain, wherever you stay. Listen to your parents, listen to your teachers, focus on your goal. That means you are the candidate of JC, so you have to be focused. Okay, because in class 9 you have to get a good subject according to your merit. So take care, take care of your parents, take care of your health while you are going outside. Use mask and also maintain the social distance. I hope all you will be healthy, sound, and you will be on your track with your lesson, and you can fulfill or achieve your goal. Thank you all. Assalamu alaikum.